steady state analysis is any sort of analysis in which uh, we do not take time as a function, right? When we do not take time as a function, we call it steady state analysis, and when we take time as a function, we call it transient analysis. Okay, so when should we take time as a function? Whenever the loads or the boundary conditions, if they're changing rapidly with respect to the time, we are going to take a transient analysis. Otherwise, we are going to take a steady state analysis. ठीक है? तो जब भी हमारे पास ये whenever we have these properties changing. So, for example, in the class we discussed an example of a weld, right? So for instance, right, say if this is if this is a weld beam, right, and it is moving, say, on this particular, this is a plate, right, and it is moving on this particular plate like this, right. So now what we are seeing is that this welding beam is moving with respect to time. So we cannot do a steady state analysis for this sort of situation. Another example is, say for example, if you're you know about swimming pools, right? So if you're jumping on a board, ठीक है, उसके साथ वो एक जो board लगा होता है, अगर आप उसके ऊपर jump कर रहे हैं, सही है, so you cannot do a steady state analysis for it. Why? Because the load is changing with respect to the time, so you cannot you cannot assume that it is a steady state analysis. You have to do a transient state analysis for it. Okay, so can you guys give me some examples, some other examples of steady state or transient analysis? Steady state is any sort of example or any sort of FEA problem where the conditions are not changing with respect to the time. So any place or anything where the loads, the boundary conditions are not changing with respect to the time are known as steady state conditions, or is known as a steady state problem. And if the conditions are changing with respect to the time, so those sort of places or those sort of things are known as transient analysis. Transient analysis means that things are changing with respect to the time. ठीक है काजी साहब? Bilkul, Taimur, you're right. So this was my next point. I was going to explain this particular point. So thank you very much for asking the question. So the thing is, in it,
सर ये ट्रांजिएंट के एनालिसिस में ये पिस्टन का जो एग्जांपल हम ले सकते हैं ना, पिस्टन?
बिल्कुल ले सकते हैं. अच्छा, ये तैमूर ने एक सवाल किया, मैं इसी सवाल को एक्सप्लेन करने लगा था, तो इसी सवाल का मैं जवाब देने लगा था, तो इससे आपको बड़ी चीजें क्लियर हो जाएंगी. Asha, okay, so Taimur, excellent question. So the thing is that there is no such thing as a steady state in the world, right? So there is no such thing. Whatever we put into, like whatever example we put into a steady state, it's not really a steady state, right? So say for example, Roman gave an example of the pedal, that is steady state, right? But the thing is, the pedal might have a load, then it might not have the load, and the load might change as well. Right, so it will not remain the same all the time. Same is the case with the example of Zarak, a bridge, right? So on that, like the cars are moving, right? So it's not purely a steady state. But what we do is that whenever we do a transient analysis, it is extremely difficult for us. It is extremely difficult for us to calculate these sort of things. ठीक है? अच्छा, so for example, whenever we are solving any equation, right? So that equation has, say, x, y, and z, 3 dimensions, and with those 3 dimensions, if we include another dimension of time, right? So obviously the equation is more complex and more complicated. So we know it through analytical equations. So in analytical equation, you would have studied heat transfer and fluid and stress. So in any of those analytical equations, whenever you add another factor of time, the equation becomes extremely complicated. Okay, so whenever we say that anything is steady state, we are actually taking an assumption that it is steady state. All right, so nothing in this world is in steady state, but whenever we say in finite element analysis that we are taking this problem as steady state, we are just taking an assumption that this particular problem is in steady state. So जब भी हम लोग ये करते हैं, तो वहां पे हम लोग आगे क्या लिखेंगे, हम लोग एक assumptions के अंदर हम लोग ये एक line लिखेंगे that we are assuming that this problem is steady state. Acha, okay. So why do we do this? Why do we take why do we put it as steady state? Because हम लोग जो है अपनी simplicity के लिए जो है तो ये करते हैं, ठीक है? So So we do this for our simplicity. That's why we do it.